Yo, what's up, everybody? Welcome to another episode of Live Learning with me, your host, Yujin Tang. So, today we're going to cover how to build a basic recurrent neural network with PyTorch. I built a bunch of these written tutorials on them on how to do them with TensorFlow Keras, mainly Keras. Keras is basically the main API for TensorFlow. So, the PyTorch version, since we've been exploring PyTorch recently, I built the convolutional neural network in PyTorch, and I'll be releasing a post on that. I know I promised a visual on the MaxPool 2D and the Conv 2D stuff, and that is coming out. I promised coming out. I'm writing it. Today I just wanted to do a video today as well, so we're gonna cover how to do a recurrent neural network in PyTorch, and I'll drop the links to how to build them, the blogs for the Keras versions. This one we're just going to cover a basic RNN. Later on we'll cover the GRU, the gated recurrent unit, and the LSTM, the long short-term memory. So first let's go and look at my old CNN code so that we have an idea of what to import. So we don't need torch vision. So let's go here. Let's do RNN datasets. We'll probably just do one of the MNIST datasets or the CIFAR dataset. Oof. So we're going to do this. We're also going to import NumPy, import pandas, and yeah, as np as pd. So I think these are the only imports we're going to need, but we can check stuff out as we go. Oh, we're also going to import, let's import matplotlib so that we can .pyplot as plt. So let's do this. Let's get an RNN. I'm gonna define a network. We're gonna go to CNN here. We're gonna look at how we define this network, and we're just gonna rebuild it entirely. So we have a class neural network. I'm gonna call it neural net, and this is gonna extend nn.module, which we extended before as well. So we're gonna need an init function, which has to call the super function, super neural network.self.init. And we're also going to need a forward function. Forward pass. Why is this yelling at me? That should be right. What is this? Oh, I didn't give it the self, of course. I forgot to find them as a function. So that's why it's yelling at me. Okay, so now the next thing we need to do is we need to create the network, the layers. So in the CNN, you can see that what we did was we created a sequential network that passed in a convolution. So here, self.network is going to equal nn.sequential. And we'll start off with let's see. So we should start off with the basic network. Let's get what data set are we going to use? Let's get the PyTorch datasets. I'm looking this up on Google, PyTorch datasets. Are they actually all in Torch Vision? No way. Okay, so Torch Vision has all the datasets. What? What? Okay. So we're going to import Torch Vision. So we're going to import from Torch Vision. Okay, wait, I want to do this the right way. So there are different arguments for what does PEP8 say? PEP8 imports. Absolute imports are recommended, blah, blah, blah. Great, so it doesn't tell, it doesn't, PEP8 doesn't give anything from this. Whether the froms should be anyway, data sets, data loaders, data loader. That's what I imported earlier, I believe. And fashion MNIST is right there, so. Data sets transformed. From Torch, you can import data loader. That's where it is. Okay. Transforms. I already imported data loader. I was just looking at it and I was like, I'm going to import this again. So, these things happen. Let's take a look at how we can start this off. So I'm not going to flatten. I don't think we need to flatten since we're not going to be doing anything crazy. We're going to be starting with the MNIST data set. So we're going to use the fashion MNIST data set. So I'm going to write that as a note here. Markdown. So let's actually, what we're going to do is we're going to load this data set first. So and then we're going to then we're going to train data. Dot size. Oh. Size? Size. No. How do we get this size? Tensor. Okay. So using fashion MNIST dataset, this is 60,000 points. Each image is a 28 by 28 pixel, 28 by 28 image. Tensor is of size 1x21 by 28 by 28. There we go. So I'm actually going to move this down here. Okay, so we're going to get a input. So this input layer, except we're going to use a torch.nn layers. Recurrent layers. So we're just going to use an RNN. There are other available layers such as LSTMs and GRUs, and we can cover those later, and they'll be basically the similar, almost the exact same implementation. The difference here is basically the actual cell, what's being implemented inside of the input. So the input size and then the hidden size, number of features in the hidden state. So let's see, input size. Wow, there's no suggestions here. This could definitely be improved. I wonder if there's a way to improve this. This could definitely be improved. Okay, let's see what the input size should be for this. Technically, I think input size should be 28 by 28. But it's kind of tough to say 28. Well, we're going to have to do some testing. So 28. Maybe it's 768. So what is 28 times 28? It's 764. 784. 784. So actually what we'll probably do is we'll probably just do a flatten. Where is the flatten? Self.flatten equals NN.flatten. There it is. Self.flatten equals NN.flatten. So actually what we're doing here is flatten. This flatten is not this flatten. This flatten is this neural network flatten with the automatic parameters. So what this means is that when we pass data to self.flatten, we're actually passing data as if we're passing data right there. So we're calling the function and then we're giving the function data. What do we do here? Oh, I don't know what we did before this. Ha! Basic NN, this one. Do we flatten it beforehand? No. Okay, so let's do linear. Sorry, input size equals 28 by 28. And then we want the output size, I believe. Or we want the number of hidden size. So hidden size, number of hidden. Let's do, this is one of those things where we could do with hyperparameter tuning or feature selection. Or sorry, yeah, hyperparameter tuning, feature selection, different things. But this one would probably be hyperparameter tuning. So hidden size is, let's say, 12. And then we want the number of layers. So this is the number of times it recurs, basically. Num layers, and I'm going to set that equal to 28. Then we can also use tan or relu for our nonlinearity. I don't think it matters, but we can just, like, you can use either one. So we're going to just do that. And now we're going to do, I think it's self.flatten, right? That's what they call it. X equals self.flatten x, yeah. Self x. X is the input. X equals self.flatten x. And then, yeah, results, basically. Results equals self.network x. Return results. Okay, so now we've created a basic neural network. Let's actually, we have to do NN.linear. Oops. Oh, I need a linear. I believe it should be 28 by 28 and 10. So actually what we're going to do here is for layer in self.network x equals layer x print x dot size return x. Now we're going to go and set the model. So we're going to set a model is equal to our neural net. So you can really set this however you would like. We're going to set a learning rate, a batch size, and a number of epochs. And then we're also going to set the loss function and the optimizer here. Usually we don't actually have to reset these every time because these are constants, but this one and this one needs to be reset every time when we do anything new with the network. So now we're going to set and we're going to define the training loop, and we'll go over this again as well as the test loop. So what we're doing here in the train loop and the test loop, right? We're giving it a data loader, which we defined up here as the training data loader with a batch size of 64. Then we're giving it a model, a loss function, and an optimizer. So yes, that's right. The training loop should take the does all the training. So we start off with this size. This is just to keep track of what batch we're on. So every 6,400 samples, we show the loss and the current number that we're at. So for each batch we do in the data loader, there's 60. Each batch size is 64, right? We go and we do the prediction. So let's actually I want to define the batch size before the data loader. It doesn't really matter, but this should be the same as this. We sent the model, and then we send the loss. Oh, so you know what? Actually, let's look at what the model looks like first. So where did I do that playing around with? Because that was annoying to do. Don't want to have to redo that. Aha! No. Oh, where did I do that? Was it here? Yes, okay. So let's do this. Let's make sure that our model makes sense. Tuple has no object size. What? What did I do wrong? Oh. What did I make this? What if I don't do this? Input must have 3 dimensions. Got 5. Okay. So here we go. Our first error that we're running into building this. Okay. Let's just print x. What is x? X becomes a tensor, 2 tensors. X becomes 2 tensors? X becomes RNN, which becomes multiple. Yeah. Oh, yeah. Okay. For recurrent in X, print recurrent dot size. Oh yeah. Whoops, we're not in Python 2 anymore. Linear argument input position 1 must be a tensor, not a tuple. Okay, because the RNN output is a tuple. So actually, in order to use it, we have to do the hidden size, which is 12. This should be 12 by 28 by 28. How do we flatten that? Let's look at our model. Print model. how do we reshape an NNN to the right? An RNN's output into the right data set. So this is a fun exercise. This is different. This is new. What did I do with TF? Input shape. I didn't do it at all. I didn't have to do this at all. All I did was get the model. Notice how this looks very different. But this is because I created a class for the model in PyTorch. Okay, let's see what the error is. So we're looking this up and doing PyTorch RNN. Should we just get... Well, okay, let's see what happens if I just do this and I don't print out the thing at all. Okay, no. So it's yeah, okay. Can I use the RNN layer in a sequential model? Is that even a thing? Okay. Warning, there are known non-determinism issues for RNN functions and versions of CU, DNN, and CUDA. The output is a tensor of shape ln d times h out. So actually what we should do is x equals, so instead of doing sequential, what we'll just do is we'll do self.rnn equals RNN layer self.output layer equals this. What we'll actually just do is self.rnn layer x, and then x equals self.output layer x 0, x negative 1 maybe. H out, yes, okay. And we'll print x dot size for each one. Let's print x dot negative 1 dot size. Excuse me? Tuple object is not callable. Tuple object is not callable? Is RNN layer a tuple object? That's a tuple? What? Excuse me? That's wild. Okay. Okay, here we go. NN by 12 and 784 by 10. How do we get 784 by 10? What? What? Is it maybe? Okay, so the output of this 28 by 12. This is, so this should be 12 by 10 basically. And okay, sick. So now we think this should work, or I think this should work. And now we're gonna go and we're gonna use the optimization loop. Here we go. All right, I'm gonna use the CNN one because I made it way better. Here we go. Oh, I need to also get this. Huh? What? This looks wrong. Oh, yes, I changed it. Yes. I was like, this looks wrong. No. So don't need to print this stuff out. Okay, let me. So don't need to print this out. Also, don't need to do that. Don't need this anymore. Okay, what's the error here? Batch size 28, input expected. Maybe it's 64 by 28 by 28. I hope it doesn't get mad at me. What the heck? Gosh, expected input batch size to match target batch size. Where is it getting this input batch size? I don't even know where it's getting this input batch size. What am I doing wrong here? Num layers, maybe? Should this be 64? No, I don't think that's right. Hello? Ah! It should be 64. Wait, that's crazy. Okay, that's... doesn't seem right. Okay, we're gonna see what happens here. That seems really... I feel like I feel like let's change the batch size because this is going to take years to train. So let me change this batch size. So this is why batch size should be defined beforehand. So we're going to do batch size here, and we're going to define it as 8. And everything that we're going to see as 64, we're going to call batch size. I'm going to get rid of this batch size. And yes, this should be batch size. That doesn't make any sense. I feel like there's a what? Oh, I didn't define it here. Yeah, okay. I'm going to figure out how this works eventually. Okay, so I'm going to let this print, and then I'll come back when it's done training. Okay, so brief loop, I had to change this model and model so that we were using the correct models here. Otherwise, it reused this model, and it needs to be passed through all of the functions correctly. On the other hand, this accuracy is trash. 10.3, 10.1, 10.3. And it doesn't look like it's repeating. 2.9 at the beginning, 2.9537. Yeah, different errors, but 10.2. Yeah, this is absolute trash. So we're gonna optimize this and make it better in a later video. But this works. This is getting the RNN to work. Okay, cool. I'll see you guys next time. Thanks for tuning in, and make sure to subscribe.